Hello friends, welcome to my channel. My name is Muhammad Luqman. I am studying in SVCE, Shri Venkateshwara College of Engineering, and I am pursuing degree in BE in CSC, Computer Science with Artificial Intelligence. And my subject is operating system. And today's topic is memory management in operating system. Let's start. Introduction. Objective and purpose of this topic. To understand the role of memory management in an operating system and explore different memory management techniques. Purpose: discuss how memory is allocated, deallocated, and managed by the operating system to ensure optimal performance. What is memory management? Definition: memory management refers to the process of managing the computer's memory resources, including both physical and virtual memory. Importance: ensures efficient utilization of memory, prevents memory leaks and fragmentation, provides isolation between processes. Key goals: efficient allocation and deallocation of memory, support for multitasking, and protection between processes. Proceed to next slide. Types of memory in a computer system: primary memory, secondary memory, cache memory, and virtual memory. Primary memory refers to RAM. It is first point. Volatile memory, which is used to store data currently being processed. Second, fast access but limit in size. Secondary memory, which refers to disk memory or ROM. Non-volatile memory, like hard drives or SSDs, used for long-term data storage, lower than RAM. Okay. Next is cache memory, small, high-speed memory located near the CPU, used to store frequently accessed data to reduce latency. Virtual memory, an abstraction of physical memory using both RAM and secondary storage. Okay, proceed to next slide. Memory management in techniques. Contiguous memory allocation. Memory is allocated in a single contiguous block. Simple but can lead to fragmentation. Example: first fit, best fit, and worst fit. Allocation strategies: pages, segmentation, and virtual machine. Okay, let's discuss about it. Contiguous memory allocation. Description: memory is allocated to processes in one contiguous block. Types of allocation: fit, first fit, best fit, virtual fit, worst fit. Okay, what are its advantages? Simple to implement and manage. Disadvantages: leads to fragmentation, both internal and external. Second, not efficient in a system with many processes. Okay, let's proceed to next slide. Paging. Definition: provides memory into fixed size blocks, collected pages, and the logical addresses. Space is divided into equal sized blocks. How it works? The operating system uses a page table to map virtual memory address to physical memory addresses. When a process needs more memory, the OS operating system loads pages from disk into available physical memory. Advantages and disadvantages. Advantages: eliminates external fragmentation, more efficient memory utilization. Disadvantages: can cause internal fragmentation, unused space within a page, requires additional overhead for managing page tables. Next, proceed to next slide. Segmentation. Definition: divides a process memory into logical segmentations such as code, data, stack, etc. How it works? Each segment has its own base address and length. Segments can grow and shrink dynamically as needed. Advantages and its disadvantages. Let's talk about advantages. More flexible than paging. Segments can grow or shrink depending on the need. Disadvantages: can lead to fragmentation, internal or external. More complex to implement than paging. Okay, next, virtual machine. Virtual memory definition. A virtual memory technique that creates the illusion of a large contiguous block of memory by using both RAM and disk space or ROM. How it works? Page swapping, page faults. First, page swapping. Parts of processors are swapped in or out of physical memory to the disk when needed. Page faults occurs when a process tries to access data not currently in RAM, triggering the OS to load the required data from disk. Advantages and disadvantages: allows the execution of larger programs than the physical memory can hold, supports multitasking and society, or isolates proceeds from each other. Disadvantages: slower than using physical memory alone. Excessive swapping can lead to thrashing, performance degradation due to consistent processing. Okay, proceed to next slide. Memory fragmentation definition. Fragmentation occurs when memory is allocated and deallocated in such a way that the memory is split into small unusual chunks. Types: extended fragmentation. Free memory is scattered in small chunks, preventing large contiguous blocks from being allocated. Types: external fragmentation. Free memory is scattered in small chunks, preventing large contiguous blocks from being allocated. Internal fragmentation. Allocated memory blocks are larger than required, wasting space within the block. Solution: compaction. Reorganizing memory to consolidate free space used in contiguous allocation. Paging reduces external fragmentation by using fixed size blocks. Okay, proceed to next slide. In this slide, key management strategies, key memory management strategies. Swapping, moving processes between RAM and disk storage. Demand paging, only loads pages into memory when they are needed. Page replacement algorithms, FIFO, LRU, and optimal page replacement. FIFO means first in first out, and LRU least recently used. And third one is optical page replacement. Okay, proceed to next slide. Summary. Key takeaways. Memory management is crucial for efficient system performance. Techniques like paging and segmentation help avoid fragmentation. Virtual memory extend physical memory, allowing larger processors to run. OS needs to balance performance and memory usage through efficient algorithm. Okay, next. Conclusion. Summary. Memory management is one of the most essential aspects of an operating system that affects its performance and multitasking capabilities. Effective memory allocation and deallocation are necessary for optimal system performance. Final thoughts. Understanding memory management techniques like paging, segmentation, and virtual memory is fundamental for system level programming and OS design. So this was the topic of operating system about memory management, and I discussed about its objective, purpose, and types. So thank you. Like, share, and subscribe. Thank you.